All right, so let's start with those two problems that we left you to try at the end of last time. So, example, these are both definite integrals that we were going to compute with substitution. So basically compute. So the first one was the integral from 0 to 1 of x squared times 1 plus 2x cubed raised to the fifth dx. So again, we want to let u be the 1 plus 2x cubed. And then du, we take the derivative implicitly on both sides as 6x squared x. And then we want to go ahead and solve for dx, so we divide by 6x squared. So du over 6x squared is dx. So again, we're using this one and this one to complete our substitution. And then we also care about what happens to our limits. So again, we want to change our limits from x values to u values. And then that way we won't have to substitute back to x. That's the nice thing about these definite integrals. So we're using the fact that u is equal to 1 plus 2x cubed. So, when x is equal to 1, what does that make u? Well, if x is equal to 1, that would mean that u is 1 plus 2 times 1 cubed, so 3. And if x is equal to 0, then u would be 1 plus 2 times 0 cubed, so u would be 1. So now we can go ahead and make our integral. So the integral is going to change into the integral now from 0 to 1. You can leave the x squared there for now. It'll cancel in a moment. And then that's going to be times u to the fifth. So that's using the top substitution that I've circled. Now we're going to replace x by du over 6x squared. So our x squareds drop out, they cancel, so we're left with only u's. So we know that we've completed the substitution appropriately. And then again, the 1/6 we can think of as just a constant on the outside. U to the fifth has a very easy antiderivative. Just add 1 to the exponent, u to the sixth over 6, and that's from 0 to 1. This thing's a polynomial, so plugging in 0 isn't going to do anything, so it's just going to be 1/6 times the 1 to the 6th power. I mean, I'll plug both in just so you can see, but 1 to the 6th over 6 minus 0 to the 6th over 6. So the second term is 0 and just goes away. So we get 1/6 times 1/6, or 1 over 36. So that was the answer to the first one. Like I said, you could have done a decimal approximation and checked on Desmos to make sure that you got the right answer. Are there any questions on that one? Were people able to get it at the end of the last class? Anybody get it right? Oh, hopefully silence is a good sign. So let's go back and look at the second one now. So the second one was an exponential, 1 to 3, 4x times e to the x squared minus 1, x squared minus 1, all in the exponent. So part B, we have the integral from 1 to 3 of 4x e to the x squared minus 1 dx. So for this one, what you want to do is you want to pick u to just be that exponent, x squared minus 1. The reason is, if you have e to the u, that's something we'll be able to take the antiderivative of quite easily. And we know the derivative of 2x of x squared minus 1 is 2x, which is only a constant away from that 4x we see multiplied in front. So that's how it's kind of reversing the chain rule there. So let u equal x squared minus 1. So du will be 2 times x dx. Then divide by 2x. That's the value of dx. Again, that's all we use is what u is and what we've solved for dx to make our substitution. So we use these two things. We also have to care about our limits. I think we can fit them in up here this time. So u is x squared minus 1. So if x was equal to 3, the top limit, that means u is going to be 3 squared minus 1. So 9 minus 1 is 8. And if x is 1, you get 1 squared minus 1, which is 0. So again, I'm just plugging them into this top thing that I've circled. The 1 and the 3 are x values, so when you plug them in, you get values of u equals 8 and u equals 0, respectively. So then our integral is going to become the integral from 0 to 8 of 4x times e to the u times du over 2x. And 4x divided by 2x comes out to 2. So we get the integral from 0 to 0 to 8 of 2 e to the u du. And that's a very easy integral because the antiderivative of e to the u is just itself e to the u. So we have 2 e to the u from 0 to 8, which is 2 e to the 8th minus 2 e to the 0, which is 2 e to the 8th, just minus 2 because e to the first is, or e to the 0 is 1. I'll go ahead and get an approximation. This is going to be a pretty big number, though, I have a feeling.
So how do you know when you're going to be changing the limits? What factor causes that?
Anytime you're doing a u substitution and it's a definite integral, you're going to have to change the limits. So because we're changing variables, we're going to have to do that. So if we had a problem where it doesn't have limits, usually what we do is we just do the antiderivative and then switch back, right? If we would look at, say, one of the examples from last class, right? We started off with just problems like this example where there's no limits, right? So that's an indefinite integral. So we're just looking for the general antiderivative. So we did the u substitution, got our answer as 1 over 24 u to the 6 plus c, and then switched back to the original variable. But that's only because it was not a definite integral, meaning there's no limits. But with the one we just did, and maybe one like this, we had limits. So rather than switch back and use the limits, it would look more complicated. It's actually much easier to do it this way, where you just switch the limits from x values to u values. If you don't need to make a substitution, you're not going to have to do anything with the limits. So this is purely something that you do when you're making a substitution, and it's going to make the problem easier. I promise you that. But yeah, I use z's here, but I switched to x's. That's fine. Okay. Again, I'm sure this seems a little mysterious at first, but the more you do it, the better things go. Wait, hold on. Did I make a? I made a mistake on the previous one. If you'll notice, I forgot to switch my limits. Right, I went from 0 to 1. Maybe that was confusing you. So on this one, I in fact switched my limits, but I did not when I did the problem. Right, I went from 0 to 1 and said that's 1 to 3, but then I failed to switch them here. So that was a mistake. So these limits that I'm plugging in are wrong. So it's going to make this part wrong. Again, that's one nice thing why it's always good to check your answers. So instead of going from 0 to 1, we should have been going from 1 to 3. So for this problem, it should be 1/6 times 3 to the 6 over 6 minus 1 to the 6th over 6. And when you plug that into your calculator, you'll end up getting something like, well, it's exactly 20.2 repeating. So I in fact, on the previous one, noted what the limit should have been, but then I didn't actually implement the change. So maybe that's why you were confused.
Yeah, that helps. Thank you.
Yeah, so there was a mistake there on the previous one. Maybe that was throwing you off.
Yeah.
I think we've done those. I'm just trying to look for some more examples here. Many of them are very similar, but let's try some from the exercises. So this next example is number 40 in section 5.4. So example, sometimes I'll note where they come from. Sometimes I can't remember, or I just made them up. So this is 5.4, number 40. So this one is the, let me make sure we didn't, all these examples start to look so similar. But yeah, no, slightly different. So this one is, again, just compute the integral from 0 to 1 of x cubed over 3x to the 4th plus 1. And again, you want to think for a second, what would your choice for u be? There's pretty much two obvious candidates, either the top or the bottom of the fraction. In this case, it's going to be the bottom, though, right? Because if you take the derivative of a polynomial of 4th degree, you end up with a polynomial of 3rd degree. So we're going to let u equal 3x to the 4th plus 1. So then du is 4 times 3, which is 12x cubed. The derivative of 1 just goes away. So we have du over 12x cubed is dx. Again, every time I'm making the substitution, I'm just using what u is and what dx is. The middle thing is just an intermediary step. What about our limits? Let's do that below, and then we'll do the integral to the side. So the limits, we have x equals 1. So that's going to be 3 times 1 to the 4th plus 1, which is 3 plus 1. So that becomes u equals 4. And then we have x equals 0. And that becomes u equals 0 plus 1, which is 1. So our integral becomes the integral from 1 to 4 of x cubed over u times du over 12x cubed. So the x cubes will cancel. I'll bring the 1/12 in front. So I have 1/12 integral from 1 to 4 of the natural, I'm doing the antiderivative already. Just 1 over u is going to be all that's left, right? Because that x cubed crosses off with that one. And the antiderivative of 1 over u is just the natural log of the absolute value of u. The limits are both positive, so you don't even really need the absolute value in this case. So the natural log of u from 1 to 4. So then you get 1/12 times the natural log of 4 minus 1 minus the natural log of 1. The natural log of 1 is just 0, so this just comes out to the natural log of 4 over 12. You can do that in your calculator if you want. It comes out to something like 0.1155. But pretty straightforward. Okay. Got a bunch more here. So why don't I do one more, then I'll give you a couple to practice. Yeah, this one's a little interesting. Again, this one is just going to be, so we're just going to review with about 5 more examples. So like I said, I'll do 3 of them, and I'll leave 2 of them for you to do. But this one's a substitution we haven't seen yet. So, and this one's just going to be an indefinite integral. So integrate. So just find the general antiderivative. So we have the integral of the natural log of x quantity squared. So that's the natural log of x times the natural log of x divided by x dx. So the u sub here is going to be u equals the natural log of x. Why? Well, because when you take the derivative of the natural log of x, you get the 1 over x. And that's where the x in the denominator is going to come from. So let's let u equal the natural log of x. So then du is 1 over x dx. And to get dx by itself, this time we'd multiply by x. So x times du is equal to dx. So again, we're using u and dx to change our integral. So the integral becomes the integral of u squared divided by x times x du. And as we see, those x's will cancel. So what we're left with is just the integral of u squared du. And that's just a polynomial. So you would add 1 to the power and then divide by it. So this would be u to the third over 3. Since this is a general antiderivative, we add that plus a constant. And u can be replaced by the natural log of x. So this would really be the natural log of x cubed over 3 plus a constant. So that's a pretty cool problem, I would say. Okay, so let me give you 2 to try, 1 definite, 1 indefinite. I'll just give you a few minutes to work on those. We won't split into groups. You can just try it independently. If anybody has any questions, they can just ask them out loud. So we won't do a breakout session. Okay, so example, say try at home. So an indefinite integral, let's just say, this will be very similar to some ones we've done. 5x squared over x cubed plus 2 to the third power dx. So again, your substitution probably should be the higher degree polynomial in the rational expression. And b, this one will be a definite integral. Let's say the integral from 0 to 1 of 1 over 3x plus 1 squared dx. So try those 2 problems. Like I said, I'll give you 5 to 8 minutes to work on these. Okay, so I'm also gauging. I've had some people asking me about the test. So I think the first test is going to be about 2 weeks from today. We have next week we'll do 5-5, and then we'll have the homework, and then I'll probably have a test review the following week, and then we'll do the test. So, something like maybe it'll be the 19th or something like that. And it'll be set up just like a homework assignment. You'll just have a limited number of attempts. Is the only difference. I'll give you 2 attempts on it.
Will the exams be set up the same way, where it's also on WebEx?
Yeah, that's just what I said. The only difference between the exam and the homework is there will only be 2 attempts rather than 5, which is I think what you normally get.
Gotcha. Okay, so the tests and the exams are the same thing.
Yeah,
Because
yeah. So when I say test and exam, so there will be 2 tests and 1 final exam.
gotcha. Okay, and so
So
the
we'll have.
tests and exams are set up the same way.
Excuse me.
You just said the tests and exams are just set up the same way. And
Yeah, yeah,
they're the
yeah. They're
same.
both
Okay,
just two attempts.
gotcha. All right.
Is there a time limit?
No,
Okay.
Will they be open for like a week, or will they just be open for a couple days, or
like a week. Yeah, something like that.
I'm sorry, did you say it was 2 attempts?
Yes.
Nice, thank you.
Mhm. Okay, has everybody had enough time to look at these, or do you want a few more minutes? Okay, then we'll go forward. So on A here, hopefully you chose u to be x cubed plus 2. So then du is going to be 3x squared dx, and solving we get du over 3x squared, that's dx. So we replace our integral. So we have the 5x squared on top. We have u to the third on the bottom now, and then dx changes into du over 3x squared. So the x squareds will both cancel out, and we'll have a constant of 5/3 on the outside. So we have 5/3 integral 1 over u to the third du. And remember, when you're integrating like that, it's probably best if you think about it as u to the negative third power. That way we can apply the power rule. So we would add 1 to the exponent. Negative, it would become -2. -3 plus 1 is -2. Then we divide by -2, right? So we'd have 5/3 times -1 over 2, u to the negative second power, plus a constant of integration. And then when you have these indefinite integrals, again, we want to switch our u back to x cubed plus 2. So we would get -5/6, and we could write that as x cubed plus 2 to the negative second plus c. Some people might choose to put it back in the fraction, because remember, negative second just means it would be the second power in the denominator. So you could write it as -5/6 times x cubed plus 2 squared plus a constant. I would not care if you stopped the step before, though. So we had a negative power where we had to apply the power rule in that problem. That was, maybe that threw you. You'll see a lot of people that have u to the negative third, and they might say, oh, well, that's u to the negative fourth over -4. But remember, when you add 1 to a negative, it's actually going to become a smaller number. Well, technically a larger number, but a number closer to 0. So any questions on the first problem, part A? Okay, the second one's going to be pretty similar. So if you messed up that part on integrating u to the negative third, you probably had an error on the next one as well, because it looks to my eye like that's going to be we're going to get something like u to the negative second because of this fraction. So again, we're going to let u equal 3x plus 1. So then du is 3 times dx. So du divided by 3 is dx. Okay, well, now we can start replacing things. Oh, we also want our limits here, because this one is a definite integral, so we don't want to switch back to x's. We just want to stay in u's. So x equals 1. We're using the u equals 3x plus 1. So that would be u equals 4 when you plug in 1 for x. And then x equals 0. We would have 3 times 0 plus 1, which would just be 1. So that changes to u equals 1. So then our integral would be the integral from 1 to 4 of 1 over u squared times du over 3. Again, there's no x's, so we're fine there. So this is just going to be the, I'm going to bring the 1/3 in front, and then we have the integral from 1 to 4. And then we want to think about that as u to the negative second du. So the antiderivative of u to the negative second, add 1 to the power, -2 plus 1 is -1, and then dividing by -1 is the same as multiplying by -1. So basically we're going to get -1/3 u to the negative first from 1 to 4. And again, u to the negative 4 first is just 1 over u. So we're going to end up with negative 1/3. And we're going to get 1 over 4, plugging in 4, minus 1 over 1. So we get negative 1/3 times negative 3/4, which leaves us with our final answer of positive 3 over 12, or positive 1 over 4. So that's the answer for part B. So any questions on either of those before we do 2 more examples and call it a day?
Yeah, so you just brought, I'm confused on how you went from u to negative 2 to u to negative 1.
So the rule, remember, so let's just remember the power rule. So power rule, this is just one of our basic antiderivative rules from 5.2. Says the integral of x to the n dx is x to the n plus 1 over n plus 1. Plus a constant if it's a general antiderivative, but when it's a definite integral, you don't need to worry about that constant. So for all intents and purposes, this, right? So, sorry, went down too far. So for our example, we had the integral of u to the negative 2. So this would be u to the negative 2 plus 1 over negative 2 plus 1, which is u to the negative 1 over negative 1, which is actually the same thing as negative 1 over u, which is what we have, right? So if you look at what happened, I brought the negative in front right here, and then this is u to the negative 1. So that's the same thing as negative 1 over u. Does that make sense?
Yeah, that helps a lot. Thank you.
Again, there's a lot of times those negative powers throw people for a loop. All right, so let's do, I'll do 2 more. So example, and again, I'm just going to say compute, but the integral kind of tells us what to do. So for part A, we'll go back to a regular one. We'll say the integral of x times e to the 2x squared dx. And again, a lot of times when you have these exponentials, you want to look at the exponent to be the candidate for u, because we know how to integrate e to the x very easily. So for this one, I'm going to let my u be 2x squared. So here I'm going to say let u be 2x squared. So du will be 4x dx, or du over 4x equals dx. Okay, so now I can do my integral. So it's going to switch to the integral of x times e to the u times this du over 4x. So the x's cancel. I'm going to bring the 1/4 in front, so I'll get 1/4 e to the integral of e to the u du. And that has a very nice antiderivative. It's just 1/4 e to the u. And again, when it's an indefinite integral, meaning there's no limits, we do that plus c. And we also switch back to from u to x. So this would be 1/4 e to the 2x squared plus a constant. And that would be it for part A. Part B here, let's say we have the integral from e to the 4th of 1 over x square root of natural log of x. Now it looks kind of complicated, but again, notice you have a natural log of x and a 1 over x. So your natural choice is going to be u equals the natural log of x, and it'll take care of that 1 over x for us. So let's let u equal natural log of x. So then du will be 1 over x dx. So x du is equal to dx. This is a definite integral here, so let's see what happens to our limits. They're easy to evaluate because, so let's say x is e to the fourth, u would be just the natural log of e to the fourth, and the natural log cancels with e, so we just get whatever the exponent is. So this would be u equals 4, and then for x equals e, the natural log of e is just 1, so u would equal 1. So now we're ready to replace our integral, change from x's to u's. So our integral is now going from 1 to 4, and it's going to be 1 over x times the square root of u times x du. So our x's cancel, and you want to think about what is the exponent of 1 over the square root of u. Well, typically u would be the 1/2 power, or the square root would be the 1/2 power. When it's in the denominator, it would be the negative 1/2 power. So 1 over the square root of u is really u to the negative 1/2 du. Again, these x's just cancel. And again, we're going to use the power rule here like we did before. So maybe I'll spell that out in a little more detail. What would we do? Well, we'd add 1 to the negative 1/2. So this would be u to the negative 1/2 plus 1 divided by negative 1/2 plus 1 from 1 to 4. Well, that's going to be u to the 1/2. And then we're dividing by 1/2, which is the same thing as multiplying by 2. So what do we get? Well, u to the 1/2 is just the square root, so we're getting 2 square root of 4 minus 2 square root of 1. So that's 4 minus 2, which is 2. So although the problem looked quite complicated, it actually had a very neat solution. Okay, so that is pretty much it for the examples I have from 5.4. Again, I encourage you to look at the homework. So the first half of the homework would be problems from 5.4. Then next week, we're going to be doing 5.5, integration by parts. And that's what the questions are from the second half there. So next week, we'll be looking at those. And then probably next Friday, we'll be doing the homework questions if there are any. Unless anyone has a particular one they would like to look at today. Again, remember I've extended that homework deadline. I've got it set up for, I think, Monday, the 15th. So you can check on WebAssign. But other than that, we will call it a day here unless there are any questions. Okay.